Hello, my name is Mike Ollerton and I'm here to discuss the importance of helping students develop confidence with their mathematics and their competence at being mathematical. A key planning issue is to offer students something that is easily accessible, which they can all make a start on. A strategy I frequently use is to ask either an open question or present an image for them to look at and discuss in pairs for the first 2 or 3 minutes. After 2 or 3 minutes, I shall ask several pairs of students to tell me one thing that they've been discussing. I won't ask for hands up because I'm more interested in just getting a general response from a group of students. So it's just one thing that I want them to tell me about they've been discussing. In response to what they tell me, I'm going to try to place here on the board what they've said. After gathering some information from the students, I will then make it a kind of an open house where I will say, well, would any other pair like to say something that hasn't already been talked about, or they can build upon something that has been already mentioned. And in this way, I'm interested in giving the students some ownership and some direction of where the lesson might be heading. I call this strategy one of drawing upon and drawing out. Drawing out and drawing upon. So having drawn out some information from them, I'm going to go a little bit further with my questioning to use what they've told me to go further with their thinking. So I'm drawing upon what they tell me, and again, this is about ownership. It's about them having a sense that this lesson isn't all done and dusted. It's about it's kind of dependent upon what we've already told the teacher. For example, a lesson aimed at summing linear sequences with a Key Stage 2 class. I know that's a Key Stage 5 topic. However, I'd been asked to do something on sequences, and I thought that's what we'll do. So I started off by asking them to tell me everything they already knew about the word sequences. If you're interested in pursuing this particular line, you might read pages 36 and 37 of Mathematics Teaching MT 271. So that's enough talking about pedagogic issues just for now, but in preparation for the next short video, I would like you to choose 3 whole numbers between 0 and 10. I'd then like you to turn them into coordinate pairs where the x ordinate, as far as you're concerned, is smaller than the y ordinate for each of the pairs. Having done that, I invite you to think about where it might go next, where you might take the lesson next, having got the students to create some data, and we'll see where that takes us. Okay. Hello again. I would love to find out what kind of ideas you came up with regards to what you might ask the students to do next, having gained these 3 pairs of coordinates. Well, obviously, we can ask them to plot the coordinates on a square grid. Now, plotting coordinates is something that children meet at the beginning of Key Stage 2 in Year 4, might even be in Year 3, but it won't be a new idea. So plotting coordinates, and of course they're all going to recognise that, assuming they've plotted them correctly, they've ended up with three with right-angled triangles. Depending on the numbers they've chosen, some might end up with isosceles right-angled triangles and some with scalene right-angled triangles. And again, there's some important vocabulary to be brought out in that simple situation. So mathematics, as well as needing to be accessible, it needs also to be extendable. And so because they're right angled triangles, and because they'll have worked on areas of shapes in Key Stage 2, then I think a nice extension task for them will be to work out the areas of their triangles. And now there are other things we can do, such as instead of plotting the coordinate pairs as x being smaller than y, what happens when y is smaller than x, when x is greater than y? Well, yeah, if you plot them, you'll find there's a very interesting geometric property to arise, and of course, why miss out on that opportunity when it's there to be had? Certainly in the lesson where I taught this with a Key Stage 2 group, the children were noticing different things, and this ultimately led me to asking them to work out, well, what would the area be for any three numbers, which I'm going to call A, B and C. I thought I'd take a chance, but certainly that kind of problem will be suitable in Year 8, Year 9 maybe. Sorry, I should have said Year 9, Year 8 maybe. But what happens if we then have six coordinate pairs and we form a hexagon? What will the area of the hexagon be, and how does that relate to the three numbers that we started off with? Of course, students are going to need some knowledge of Pythagoras' theorem in order to be able to work out the perimeters of the triangles and of the hexagon. But it's all there to be had, depending upon who we're working with, and what knowledge one would expect students to have in order to be able to work on more complex problems. And if you want something for your A-level students, then try turning the three numbers into three-dimensional coordinates, or coordinates in a three-dimensional plane. Do you call coordinates triordinates? I'm not sure. Anyway, it doesn't matter, but what does matter is that there's a cracking problem there for our GCSE A-level students, which is, so plot the six points on a 3D grid. What shape do you get? What will its volume be? What would its surface area be? All kinds of potential developments, starting from think of three numbers. Again, the triangle problem is written up in the same article that I referenced in the first video. Excuse me. In the first video, in MT271. Okay, thank you. Bye for now.